The next important topic in Python programming is loops. We know what is meant by an iteration. An iteration is the repeated execution of the same block of statements. In C language, we had three different types of loops, but basic categories of loops were the entry control loop statements and exit control loop statements. That means there were three different statements available like do while and for. Whereas in Python we have only two types of loops called while loop and for loop. We don't have any do while loop in Python. So a loop is a block of statements executed repeatedly until the given condition becomes false. So let us see what the loops available in Python are. Loop statement allows executing a statement or group of statements multiple times. That means the same set of statements or the same statement will be executed repeatedly until a given condition becomes false. So let us see what are they. Python programming language provides following three types of loops called the while loop, the for loop, and nested loops. Nesting of loops is actually not considered as a type of loop because a loop may be executed within another loop. So in that case we call that as nesting of loops. So the first one, while loop. We know while loop is a entry control loop statement. That means the condition is evaluated first. If the condition is true, then only the block of statements are executed, otherwise the block is skipped for execution. So the while loop is in Python like this, while the expression with the ending symbol colon for indicating the end of the term, the condition or expression. Then the block of statements. Here also the same, the indentation is most important. Next, when a given condition is true, then the statement or group of statement repeats, which are in the loop body. See the flowchart. This is the condition to be evaluated. If it is true, then the block is executed. After completing the execution, it returns to the condition evaluation again, and it continues to execute the same block until it becomes false. When it is false, it continues to normal sequence of operations. Example, count equal to 0, a new variable taken with initialized 0, 0 less than 5, condition true, it's not semicolon, note it down, again it's a colon, print the count is comma count. That means the count is printed one by one. Afterwards, count is incremented by 1. There is no increment operator available in Python like count plus plus. We have to write either count equal to count plus 1 or count plus equal to 1 only. So here, since 0 is less than 5, count equal to 1, it is 0 printed. After that, 0 is printed. After that, count is incremented by 1. So 0 plus 1, it becomes 1. So 1 less than 5, true, so count is printed as 1. Next it becomes 2. 2 less than 5, condition true, 2 is printed. Again it is incremented by 3. 3 less than 5, condition true, 3 is printed. Afterwards 4, it is going to be incremented. 4 less than 5, true, 4 is printed. Then 5 it becomes, 5 less than 5 is false, so it says goodbye. See the output. Count is 0, count is 1, count is 2, count is 3, count is 4. Using else statement with while loop. This is another important change in Python. If the else statement is used with a while loop, then the else statement is executed when the condition becomes false. So when the condition is false, the else part is executed. See that. Count equal to 10. 10 less than 5 is false. Then it is another block we have defined which is going to justify why the loop is terminated. That means here 10 less than 5 false, so the control comes to the normal sequence of operations, but it doesn't give any information why it came out of the loop. So to give complete information to the user why the loop doesn't execute or didn't execute, an else block is defined with while loop in Python. This is one of the useful features in Python. So then the output is 10 is not less than 5. Okay. Next, for loop. For loop is, we know, for loop is always useful loop in any programming language. For is used to specify the number of times a particular block of statements have to be executed. So here, for iterating a var in sequence, we use this particular for iterating variable in sequence. So it is something differently defined. That means lower bound and upper bound are specified with the for statement itself. If a sequence contains an expression list, it is evaluated first. Then the first item in the sequence is assigned to the iterating variable. Next, the statement block is executed. Each item in the list is assigned to iterating variable and the statements block is executed until the entire sequence is exhausted. Sequence means you may specify it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times the loop is repeated. So flowchart, the same thing we had seen, just like your while loop. See the example. S1 ECE for letter in S1. That means each letter is assigned to this letter variable in S1. So it is in is a member type or operator, member operator. This is the list available. In this list, the values are, the characters are one by one assigned to letter and the corresponding value is printed. So print current letter, comma letter. See the output, current letter E, current letter C, current letter E. Whereas fruits is a list that is given. Of course, we have not yet learnt the fruits. So fruits is a list that contains 3 values. For each fruit, the strings are assigned. For fruit in fruits, fruits is the list and each value is assigned to the fruit variable each time the loop is executed. Current fruit is banana, apple and mango. The next one is nested loops, Python nested loops. Writing one loop inside another loop is called nesting of loops. The syntax for nested loop statement is as follows. It is for loop. You can write a while loop in for loop or for loop in a while loop or while loop in a while loop or for loop in a for loop. Let us see that. For iterating variable in sequence, again for iterating variable in sequence, statements. See the output. The next syntax for nested while loop statement is also the same. The program to find the prime numbers from 2 to 50 is an example we have considered here. I is assigned to 2, I less than 25, j equal to 2, j less than or equal to I by j. The value of j is used with I by j, not I percentile j break j equal to j plus 1, and the corresponding prime is printed here. There is a different types of loops available. Here, if the value of j is greater than I by j, it means that there is a no separate, no exclusive factor available other than 1 and itself. This loop is actually meant for finding the factors for any given number below half of its number. So if not I percentile j, that means if it is not equal to, not or false or true, whatever it may be, I percentile j equal to 0. If it is not, then break is done. That means if it is not, I mean to say, if it is not divisible, or if it is divisible, then the control is breaking. That is, the total block is terminated, and it comes out to this case. If j is greater than I by j, see, for any prime number we have the factors 1 and itself, some x. So if any factor is found in between these values, then the corresponding number is not a prime number. So using this logic, this program has been developed. Output 2 is prime, 3 is prime, up to 23 is prime. Break and continue statements. and else clauses in loops. The break statement is used in loop control statements such as while or for statements to terminate the execution of the loop. We have seen this in C programming. When the keyword break is encountered inside any loop or control automatically skip entire loop and passes to the normal sequence of operations available after the loop. Next syntax is break followed by simply break inside any block. The continue statement is used in while and for statements to terminate the current iteration of the loop and continue with the next iteration. When the keyword continue is encountered inside any loop, compiler or interpreter skips the remaining statements available after the continue statement and control reaches to the next iteration or beginning of the loop. Syntax just continue. Anywhere you can use without any block or condition. Loop statements may have an else clause. It is executed when the loop terminates through exhaustion of the list with for or when the condition becomes false in while, but not when the loop is terminated by break statement. If the break statement is used in the for statement or while statement along with the else statement, then the else will not be executed. It is entirely terminated. As we have seen, else is used to specify why the loop was not executed. So examples, for letter in Python, if letter equal to H, break, the current letter is printed. That means PYT will only be printed in this example. Similarly here, other than H, the remaining letters are printed. See this, PYT, when the letter equal to H, continue. That means the control returns to the beginning of the statement. Range. Range is a function used to iterate over a sequence of numbers. It generates a list containing arithmetic progressions. Example, range of 10, 0 to 9. Example, range of 5, 10, 5, 6, 7, 8, 9. Starting value is specified. From 5 to 10, the range is generated. To iterate over the indices of sequence, you can combine range and len as follows. A equal to Mary had a little lamb. For I in range, len of A, print I, A of I. Output 0. For 0th index, A of I, len of A is considered. Then had is generated, A is generated, and so on. This we see clearly in lists later. For n in range 2 to 10, that means phi equal to 2, I less than or equal to 10, I plus plus is the relevant statement in C programming. Similarly for x in range 2 to n, so the n is divided by x, and if it is equal to 0, the value is printed. That is, the mathematical table is generated probably. So prime numbers and so on. So 2 is a prime number, 3 is a prime number, 4 equals 2 into 2, 6 equals 2 into 3. Other than the prime numbers, what are the results of the corresponding numbers is generated by this simple program. This we see clearly later in while working with the practical sessions. Pass statement is another statement used when a statement is required syntactically but we do not want any command or code to execute. The pass statement is a null operation. Nothing happens when it executes. Syntax. Example. For letter in Python, if letter equal to H, pass. That means that H is not generated. See, this is pass block. That means just simply it is passes. Python, H is generated, but whenever it is equal, just a simple pass is given. Pass statement is used when a statement is required syntactically but we do not want to. This is again repeated, sorry. Thank you for this looping statements. Later we see the lists and tuples. Thank you.